Assalamualaikum and hi. My name is Muhammad Zaid bin Muhammad Rozali. My matric number is A19A0317. I would like to introduce my team members. Nurul Alia Maisara binti Sobri, Wan Hafizul Arif bin Wan Ahmad, Mustaqim bin Mustafa, Nurul Izzati binti Harrison. Our team members group lead the project Robotic Safe-Picking Warehouse for our team project assignment. What factor influence our choice to support this robotic system, and what are the most common picking issues encountered in the warehouse? So, in response to the query, I would like to discuss abstract in this project. Abstract. So, what is a warehouse with robotic safe picking? The robotic safe picking warehouse is an engineer's wheel platform capable of autonomously transporting things from one spot to another, while people continue to perform the more difficult tasks such as picking items from shelves. Sometimes, the issue in the warehouse is the risk of moving items. It takes a long time and needs additional people to speed up the process. Robotic logistics enable increased operational time in manual labor-intensive professions, resulting in the exchange output across a range of professional settings. Hopefully, the robotic safe-picking warehouse will reduce some of the stress on users, particularly warehouse picker.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Izzati binti Harrison. My number matric is A19A0753. I will be presenting about motivation or background about IM Robotics. Pittsburgh-based startup IM Robotics has developed an autonomous mobile picking robot called Swift. The robot is capable of autonomously navigating warehouses and picking at human-level speed of 200 picks per hour. The robot queries a database containing items that have already been scanned in 3D, modeled and analyzed to determine the best possible grasping strategies. IM Robotics is currently working on a pilot project with Roster Drug Cooperative, one of the country's largest healthcare distribution companies. IM Robotics is working on autonomously picking items from shelves. There are some questions from interview with Tom Gulazzo. First is, how did he come to make the decision to begin there? The answer is, Tom Gulazzo answered that as a robotic research, he was working at Carnegie Mellon National Robotics Engineering Center on a DARPA project called ARMS, which was forerunner to the DARPA Robotic Challenge. DARPA essentially wanted us to manipulate everyday objects with an autonomous manipulation robot. So, they were doing things on our own, like finding objects on a table, picking them up, moving them around. They were really tired with difficult things like changing a tire, assembly part, and all sort of other things. This is a difficult problem, but they were confident that they could add value, and then manipulation was the key differentiator there. Being able to see and manipulate those products. Next question is the kind of constraint on picking system. He said that it must be well organized. The product must support one another because they are pushing on them from the front. And if you have light product that don't have anything behind them, they will tip over. The economics of picking are such that when you are putting things away, you only need to walk to a location once with a case of product. On a picking site, there is a lot of more work. The third question is hardware and software that using for perception. The answer is they have layered on what they call their rapid vision algorithm, which process the data extremely quickly, extract the information that they need to know about the picking and match it to that which has already been visual trained for their system. The visual training comes from packaging their rapid vision system into a standalone little photo studio scanner called Flash. It is just a standalone miniature photo booth and they work up and down each islet once barcode scan each other and place a product sample in the scanner. The last question is how would to change their system in order to address that market. Tunggulazo said 75% of the item in the grocery store are pickable with a suction cup. He said they just need more variety in terms of size, shape and weight capability. So instead of a single suction cup, they already have an array from which to choose a variety of sizes. That's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum and hi everyone. My name is Mustaqim bin Mustafa. My mention number A19A0391. In my past, I would like to present about problem statement. The first problem statement is manufacturing procedure. Manufacturing procedure in robotic have seen many signage. Okay. When it comes to equipment, an expensive number of mechanical and commercial robots are still made from years and engine and tautas. These parts are still assisted robot in development as well as for other capacity part make the robot unbending and unsteady. Next is the challenge overcome when creating a robotic is able, less helpless to harm and less joint and interfacing parts. Next is mapping environment. Robots are still not able to explore through different in their ways. Even if the robot is trained to understand its environment, this slightest of iteration required the robots to relearn and adapt to the new environment. Okay. This can possibly lead to delay in carrying out the site task or even cause accident, like for machine learning and computer vision technology are currently being leveraged to overcome the mapping challenge. Okay. For example, is two animals can perform best under the controller condition. Lastly is the minimizing privacy and security risk. The information utilized for preparing robots can be ambushed by reconstructing or adjusting it to cause the robot glitch. Gathering the security of information continuously remains a major concern when utilizing mechanical agreement. Okay, that's all from me. Thank you.
Assalamualaikum. My name is Nurul Adem Masara binti Sabri. My metric number is A190709. I would like to present for the model for the robot picking, chef picking. So here for the discussion, for the first discussion, robotic shelf picking warehouse in supply chain can help to cut down the redundant process of sorting, and workers can take on more creative and collaborative rates. Then robot can work side by side with worker and take the dangerous part of job, such as getting inventory from height or carrying heavy loads. Then we would like to innovate the robot with large robotic arm that can move according to the programming to the exact location of thousands of products. Lastly, the robotic were provided with thermal sensor and haptic sensor. Thermal sensor to measure ambient temperature on the surface, and then for the haptic sensor to allow robot to perceive touch. Lastly, this robot make it easier to handle, to increase demand because of the ability to work around the clock without damage the performance. I think that's all from me. Thank you.
Assalamualaikum and hi. My name is Wan Hafizul Arif bin Ahmad, A19A0972. So I will present about the expert contribution. Expert contribution, the means of supply chain innovation and value creation for robotic chef picking is the ability to reduce direct and indirect operational costs while also enhancing revenue possibility. I have divided by 5 of the robotic chef picking particular use when it comes to first improve workplace safety for workers who were in high risk situation. Next, increase revenue is the first objective when it comes to optimizing revenue. Third one, reduce errors, correct errors and take on the risk. Next, to increase efficiency and productivity. And the last one, concentrate our resource on less routine. So that is for the expert contribution.
This love, I spend my